Hi all, we are from Group 6 Section 2. The title of our topic today is Wastewater Treatment Technologies from Rubber Industry. According to Economic History of Malaysia, EHM, as global demand for natural rubber increased and rubber prices rose sharply towards the end of the first decade of the 20th century, rubber planting became highly profitable and rubber plantations spread across the Malay Peninsula. The government has further fine-tuned the incentives to promote rubber products industry. There are several impacts of rubber industry towards environment. Firstly, wastewater from rubber industry. Since rubber industry uses chemicals and other utilities and produces enormous amounts of effluent, discharge of untreated rubber effluent to waterways resulted in water pollution that affected the human health. The main source of the pollutants is the coagulation serum, field latex coagulation, and skim latex coagulation. These compounds will result in high oxygen consumption upon discharge of wastewater. Secondly, rubber industry also contribute to other environmental problems besides wastewater discharge such as air pollution. In rubber sheet drying industry, smoke particles contribute to pollution in workplace and neighboring atmosphere. The high concentration of aerosol particles in the atmosphere can cause adverse effects on the worker's health. Problem statement: rubber industry is an economically and socially significant industry. It uses a large volume of water, chemical, and other utilities to be produced. As for the result, it also produces huge amount of wastewater and effluent. The discharge of untreated rubber effluent of waterways resulted in water pollution that affected the human health. Without any proper treatment, the discharge of wastewater from rubber industry to the environment may cause serious and prolonged consequences. Moving on to the literature review. The rubber industry is a major resource-based sector worldwide. Without proper treatment, the discharge of wastewater from rubber processing industry to the environment may cause serious and prolonged consequences. Rubber wastewater is typically treated using pond technology, as well as aerobic and anaerobic processes. Biological treatment of rubber wastewater reduces by the most. Wetland waste treatment systems and in situ hypochlorous acid generation could be used in wastewater treatment. In terms of methodology, we would like to discuss firstly waste disposal measures. It was a waste treatment practices that may alter in like manner to the characteristics of profluent releases and admissible confinements. Some in-plant control measures will be introduced to enable reduction in consumption of water, generation of pollutants and to extend the efficiency of the end-of-process wastewater treatment. Secondly, in the crepe and crumb rubber units that handle field coagulum, the amount of water consumed in milling can be minimized if the raw scrap rubber is thoroughly soaked and primary dirt removal is done by scrap washer. It is recommended that the right acid content and coagulation duration be used to get a more or less clear liquid after full coagulation. If the skim latex is deammoniated prior to coagulation, the acid demand can be lowered, as well as the ammonia concentration in the effluent. In methodology also, we would discuss about end-of-process treatment. Basically, wastewater treatment can be divided into pre-treatment, primary treatment, secondary treatment, and tertiary treatment. Pre-treatment, the rubber trap used to catch suspended materials should have a 12-hour retention capacity and proper baffles to create a continuous up and down flow pattern. This can minimize suspended solids by 40 to 60% if appropriately built. In primary treatment, for a latex processing unit, effluent from the equalization tank to be sent for neutralization and chemical treatment by alum and iron salt. Secondary treatment is a biological process which makes use of microbes or bacteria and algae to absorb the organic matter present in wastewater. The methods outlined above will result in significant reductions in pollutants, particularly BOD and suspended solids. In tertiary treatment, chlorine and chloramines are used for wastewater treatment for disinfection processes. UV radiations are used to disinfect the water. Besides, there are some advanced rubber wastewater treatment methods been introduced and proved to be useful in wastewater treatment in rubber industry. Natural processes such as biological method, chemical methods, ozonation, combination of physical, biological and chemical methods. For biological method, it can remove over 95% of BOD, while for pond technology, it has the capability of removing over 95% biological oxygen demand, BOD, from rubber wastewater. There are major issues caused by the rubber industries to our environment of nature. The major issues include high concentration of BOD, COD, and SS, acidic effluent, high concentration of ammonia and nitrogen compounds, high level of sulfate and high level of odor. In Malaysia, many techniques have recently been employed to clean rubber effluent. In general, these revolutionary procedures can speed up the generation of high-quality effluent from rubber wastewater treatment.